Hello friends, welcome back to my YouTube channel. This is part number 11 of my discussion on adsorption, and from this video lecture I will be starting my discussion on stage-wise adsorption, and this will be an introductory video on stage-wise adsorption. So let us start the discussion. Okay, to begin with, let us have a general discussion about adsorption operations. So adsorption, it has a wide range of applications. It is used to recover vapors from their dilute mixtures with gases. It is used for recovering solute from liquid solutions. It is used for removing contaminants from liquid solutions. It is used for fractionation of gas mixtures where components of a gaseous mixtures are separated. Similarly, it is used for fractionation of liquid solutions where components of liquid solutions are separated. It could be carried out in a stage-wise manner, or you can carry out in a continuous, that is both stage-wise contacting method and continuous contacting method. Both methods are in use. And it could be carried out as a batch operation, or you could carry out it as a semi-batch operation, and you could carry out it as a continuous operation. So as compared to other separation methods like distillation, liquid-liquid extraction, it is possible to carry out adsorption in a semi-batch manner. The adsorbent phase, it can be kept confined to a fixed bed, whereas the fluid phase, it can be passed continuously through that fixed bed. So in this way, the operation can be carried out in a semi-batch manner. So in one way, adsorption is a versatile separation method, separation operation. Then we can compare adsorption with other separation methods for calculation purpose. How? Let us understand. So for example, if only one component is strongly adsorbed, so if you have two components, let us say a binary mixture of A and B, and when only one component, let us say A, is strongly adsorbed and adsorption with D is neglected, then in that case, the operation can be considered to be analogous to gas absorption. So let us understand this. In the adsorbent, in the case of adsorption, is equivalent to solvent in the case of gas absorption. So that means when only one component is strongly adsorbed, we can say that adsorption is analogous to gas absorption, as at least for calculation purposes. For calculations, the two operations can be considered to be analogous. When only one component gets strongly adsorbed, then it is analogous to gas absorption. And what is the analogy? The adsorbent in adsorption, it is equivalent to the solvent in gas absorption. So let us understand it with the help of a simple schematic diagram. Say for example, you have this gaseous mixture of two components A and B, and as I said, only A is strongly adsorbed. So when you contact this gaseous mixture with the adsorbent phase, it will be going preferentially onto the surface of the adsorbent. So here A is getting adsorbed on the surface of adsorbent. Now, how it is analogous to gas absorption, let us understand. So let us say that the operation is, I'm showing the gas adsorption operation. So you have the gaseous mixture, and in gas absorption, the gaseous mixture is contacted with a suitable liquid, and that liquid is nothing but solvent. So once the two phases, liquid and gas phases, they are contacted, means what happens? A component A from the gas mixture will be getting transferred to the solvent phase. So you can see an analogy between adsorption and gas absorption. In adsorption, A is getting preferentially concentrated on the surface of the adsorbent, and in the case of gas absorption, A is getting preferentially dissolved in the solvent phase. So in this case, adsorbent in adsorption is analogous to solvent in gas absorption. So this is the solvent. Let me just show that. This is solvent. This is the solvent. Very shortly, I will be starting my discussion on gas absorption as well. So in that way, adsorption is analogous to gas absorption when only one component is strongly adsorbed. So for calculation purposes, the two operations can be considered to be analogous. Then in the other case, when both components, that is in a binary mixture of A and B, if both components are strongly adsorbed, then the adsorption operation can be considered analogous to liquid extraction. So in this case, the adsorbent, in the case of adsorbent in adsorption, it is equivalent to the solvent in liquid extraction. So again, you can look at the example. You have the binary mixture of A and B. We are contacting it with a suitable adsorbent, and then both the components are going to get adsorbed on the surface of the adsorbent. So in that way, during adsorption, A and B, they get differentially distributed between the solid phase and the liquid, solid phase and the gas phase. Now let us see what happens in liquid extraction. So you have the mixture. Now you have a liquid mixture, liquid solution. So when you are comparing it with liquid extraction, this would be a liquid solution, liquid solution of A and B. And A and B both are getting adsorbed on the surface of the adsorbent, and therefore there is differential distribution of A and B between the liquid phase and the solid phase. So in the case of liquid extraction, the liquid solution is contacted with another insoluble liquid phase, which is nothing but the solvent. And during this happening, both A and B, they are going to get dissolved into the liquid. That is, during liquid extraction, there is differential distribution of A and B between the two liquid phases, the feed solution and the solvent phase. So in this way, adsorbent in adsorption, in the case of a binary liquid solution, is analogous to liquid-liquid extraction for calculation purposes. So in this way, you can say that adsorption is analogous to other separation methods, gas absorption and liquid extraction. And for calculation purposes, this adsorption is considered to be analogous to these operations. So I hope the analogy is clear to you. And again, I'm discussing this analogy from the point of view of calculations. So the point is, the calculation methods that you have used for liquid extraction or that you have used for gas absorption, they can be used for adsorption as well. So I hope the concept is clear to you. If you have any doubt, please let me know. Now let us talk about stagewise adsorption, where it is used mostly. Stagewise adsorption, it is employed to remove solutes from liquid solution. So stagewise operation is practical to carry out in the case of liquid solutions. That is, in the case where components from liquid solutions are to be adsorbed. So stage-wise adsorption, first thing that we are noting over here is it is employed to remove solutes from liquid solutions. In this case, in the stage-wise operation, as was the case with liquid extraction and leaching, here also each stage in the stage-wise adsorption operation, it should have provision for intimately contacting adsorbent and fluid phase. And after the intimate contact for sufficiently long time, there should be a provision for physically separating the two phases. So physically separating the two phases after they are in contact for a sufficient time. So there should be two provisions. One is for intimate contact for a sufficiently long time, and the other provision is for physically separating the two phases. So for batch operations, if you are carrying out batch operations, then you can have this arrangement. A stage will have this arrangement. So there will be a agitated treating tank where the feed solution and the adsorbent phase, they will be agitated in the tank so that they are intimately mixed. They are intimately contacted with each other. And during this contact, a slurry will be formed, and then this slurry is transferred to a filter press where a filtrate will be obtained and filter cake will be obtained. Now this filtered solution will be sent for further adsorption, or if it is a single stage operation, the filtered solution will be obtained and the cake will be nothing but the adsorbent phase that has solute adsorbed on its surface. So in this way, for batch operation, a single stage will have this two equipment: agitated treating tank where the feed solution is mixed with the adsorbent phase and they are agitated thoroughly so that you have a slurry. Then this slurry is transferred to a filter press where you are getting clear filtered solution and the cake. So combination of these two equipment, it constitutes one stage in the case of batch operations. So I hope this is clear to you. So this is one stage. Then you can add more stages by adding more treating tanks and then filter press. Okay, so this is a stage for multiple operations. As I said, for multi-stage operation, you can have additional tanks and filters. Those can be added as per requirement. The operation, it can be made continuous. You can make the operation continuous. This is a provision for doing it in a batch-wise manner. You can make it continuous. How are you going to make that? One thing is you can replace the filter press with centrifuge or continuous rotary filter. So you simply replace this filter press with a centrifuge or with a continuous rotary filter. Then the operation can be made continuous, stage-wise continuous operation. And the other thing that you can do is the solid adsorbent phase. It can be allowed to settle by passing the slurry through a large tank. So in that way, the adsorbent will be continuously settling and the clear filtered and clear solution will then be moving on to the next stage. Okay, so as I said, the operation, it can be made continuous. How are you going to do that? You are going to do it by replacing the filter press in a batch operation with a centrifuge or continuous rotary filter, or you can allow the solid adsorbent phase to settle by passing the slurry through a large tank. The schematic arrangement is the schematic diagram for this I am showing. So you have the agitated treated tank where you are mixing the feed solution with the adsorbent phase, and after intimate contact, the resulting slurry, it will be sent to a large tank where the solid adsorbent phase, it will be allowed to settle and the clear solution will remain on the top of the settled solid adsorbent phase. And then after that, you can take out the clear solution and the settled solid adsorbent phase. So if you have to make it a continuous stage-wise operation, then this would be the arrangement. So this will constitute one stage. This will constitute one stage. So this will constitute one stage in the case of continuous stage-wise contact. So this will be constituting one stage. So in this way, stage-wise adsorption operation is carried out. So I have discussed how it is carried out in a batch-wise manner, and then how it is carried out in a continuous stage-wise manner. I hope you must have understood the concepts. If you have any doubt, you please let me know in the comment section. I will end my discussion for this video lecture. So I'm sure at the end of this discussion, you must have understood how stage-wise adsorption is carried out, how a single stage or how a stage is constituted in the case of adsorption operation. So with this, I will end my discussion for this video lecture. In my next video lecture, I will be discussing the single stage adsorption operation. So thanks for watching this video lecture. Do subscribe to my channel. Tell your friends to subscribe to it. Hit the bell icon so that you will be notified as soon as I upload any new video on my YouTube channel. In my next video lecture, I will be discussing single stage adsorption operation. For now, have a nice day. Thank you and bye-bye.